Physics problem related to Doppler effect of sound. The police car that was ringing a 930 Hz siren chased after someone who ran away on a motorcycle with a speed of 72 kilometers per hour. The speed of the police car reaches 108 kilometers per hour. If the temperature of the air is 18 degrees Celsius, what is the frequency of the siren sound heard by the motorcyclist? So, to answer this problem, first we need to correctly identify the given variables. For the source of sound, the police car produces 930 Hz, while the observer, which is the motorcycle, it has a speed of 72 kilometers per hour or 20 meters per second, while the police car, which is the source of sound, has a speed of 108 kilometers per hour or 30 meters per second, and the given temperature in the problem is 18 degrees Celsius, which is the temperature of the air. Now, for the required answer, we need to get the frequency of the sound heard by the observer. So, we need to calculate for FO. Now, for the first step, we need to calculate the speed of the sound using the formula of 331 meters per second plus the product of 0.6 and the given temperature. The given temperature is 18 degrees, then we multiply to 0.6, the product is 10.8 plus 331, therefore the final speed of the sound is 341.8 meters per second. Now that we have the speed of the sound, we can now proceed to calculate the frequency of the sound heard by the observer. Using the formula of Doppler effect, we can calculate the frequency of the sound heard by the observer. Now, we need to take note that whenever we use this formula, we need to follow the correct sign rule. Now, let's first analyze the motion of the observer. Since the observer is running away from the source, then we need to put a negative sign for the speed of the observer. While for the source of sound, the police car is chasing the motorcycle, which means that the source of sound is approaching the observer. So again, the rule is we need to put a negative sign whenever the source is approaching the observer. Now, the next step is to plug in all the given values. For the frequency source of sound, we have 930. For the speed of the sound, we have 341.8, which we have already calculated a while ago. For the speed of the observer, we have 20 meters per second. And for the speed of the source, which is the police car, we have 30 meters per second. Again, both of the speed should have a negative sign. That's why we need to put a minus operation in this problem. So, plug in chug in our calculator. We have 321.8 divided by 311.8. Getting the quotient, we have 1.032071.841 times 930. Then our final answer will be 959.83 Hz, which is the frequency of the sound heard by the motorcyclist.